In this video, we have a pretty far destination ahead of us, just a couple hundred light years away, and get to the HD 14283 star, or its nickname, Methuselah. Before we get into the video and the star, let's learn what Methuselah means. Methuselah is a legendary man that has been written about in the Bible, and he's known as the oldest man in this book. It has been written that he aged 969 years, and that's a little bit more than Noah. Noah has aged 950 years in the Bible. So we know that based on the Bible, Methuselah has aged the most, and that's why his name is on this star. The reason for this name is that some scientists and astronomers believe that this star is the oldest star in the universe, older than the universe itself. Astronomers and most scientists believe that the entire age of the universe is 13.7 billion years old, but they believe that Methuselah is 14.5 billion years old. But most physicists and astronomers believe that this is all bull. The age of this star is not even the same as the Milky Way galaxy, let alone older than the universe itself. But anyways, how is the age of a star determined? How do they actually calculate it? When you want to get the age of a star, you have to take three things into consideration. The easiest step is its brightness, and with today's technology and the tools available to us, they can find the brightness very easily. The second thing we have to find out is its distance. But how do we get the distance? To get the distance of a certain star, we need at least 6 months' time. Like for example, in the middle of the summer in June, you take a picture of the star and you wait 6 more months after, basically in December, and you take another picture. The difference between these two photos allows scientists and physicists to figure out how far this star is. You can even test this out with your finger. Just hold it in front of you and open your left eye and vice versa and see the difference. This is exactly what's happening with the telescopes on Earth, but it needs 6 months' time. Of course, a lot of math goes into it to figure out the distance. It's not like just the basic formula. In these 2 seasons, if the star moves a lot, that means the star is very close to us. But if it barely moves, and the less the movement get, the farther that star is. So the first step was brightness, the second step was the distance, and the third step, which is the weirdest and most difficult one, is the metallicity, or in simple term, how much metal is inside this star. But what does metal mean? Stars are made of metals? If you've seen our video about different elements like gold, iron, and carbon, you'll know that these elements were made under extreme heat, temperature, and pressures inside a dying star. In astronomy, anything that's heavier than hydrogen is considered a metal. Although that's not true because a carbon or helium is not metal, it just makes their wording much easier to call it a metal. They also call it heavy elements as well. Usually the younger or most ancient stars have the least amount of metals, and the more fuel they have, basically hydrogen. But the older the star gets, the more the fuel gets used up, and through fusion, heavier elements are created, and that creates helium, carbon, and many other elements. When you have more metals inside the star compared to hydrogen, the metallicity of that star is getting higher and higher. Or in other words, their star is getting older if it has a whole lot of metals in it. But by getting old, we're talking about billions of years, because it's not like they live a few million years. But it's interesting to know that the oldest, most ancient stars that have been discovered, they have a very low metallicity. And the reason for that is, when the Big Bang happened and the universe was extremely young, hydrogen was the only element available in the universe. So these stars that were created had an extremely high amount of hydrogen. And also, the data that the scientists receive is from more than 10 billion years ago. When the star gets to us, that's when the star was actually young. Of course, that star is most likely dead, but that's the data they have. At that time, the only elements available in the universe were hydrogen and helium, because other elements had not been created yet. That was the job of a star. And eventually, after billions of years, when it dies, it scatters all those elements through the universe. So in simple terms, to figure out the age of a star, you have to put these three main steps together to determine how old this star is. And of course, this is a theory still. They can't truly say exactly how old this star is, but they can get pretty close. But let's get back to Methuselah. Why is this star considered the oldest star in the universe? You have to know that this was a simple mistake that was done by the University of Pennsylvania. In the year 2012, this university was using the Hubble telescope to look at Methuselah, and the three basic steps we explained to you guys, they were doing the same thing to figure out how old this star is. When they get all this data, they have to do a whole lot of formula and math to figure out and get an estimate on how old the star is. But it seems like in their calculation they made simple mistakes here and there, and they got an absurd number, a number that's older than the universe itself. Their number was 14.5 billion years old. And when they announced this number to the scientific community, a lot of arguments started to take place here and there, because from the get-go, nobody believed this number. It got even more crazy because regular people started talking about it in normal media channels, because it was such a big deal on paper and it was kind of clickbaity. And that's when they named this star Methuselah, the oldest person in the Bible. Just like we said, most scientists were skeptical about this number, so they decided to do their own research to figure out why these guys got such a high number. They believe that if all this is wrong, then that means the Big Bang Theory is completely wrong too, because how could a star exist if the universe doesn't exist yet? The agency that actually took this serious and they started to do their own calculation was the European Space Agency. After 5 years of research, they estimate that the age of this star is about 12 billion years old. So that means it was born after the Big Bang, since the Big Bang happened 13.7 billion years ago. But this still makes the Methuselah star the oldest studied star. There could be much older stars, but this is the only one we've discovered. The most interesting part about this star is that an average lifespan of a star in the universe is between 1 to 10 billion years. And right now, Methuselah is the only star that has passed 10 billion years old. We've said this plenty of times and a lot of videos has been made. But usually when a star gets very old, they slowly turn into a red supergiant when they start to run out of fuel. And eventually, after billions of years, they explode in a supernova, scattering everything throughout the galaxy. But the awesome part is that Methuselah has not turned into a red supergiant because it's still a normal star. Our own sun is only 5 billion years old, so it has about 5 more before we have to worry about it turning into a supergiant, basically destroying the entire solar system. There's a star close by us named Betelgeuse, and right now it's a red supergiant, and some scientists believe that it's going to explode in a supernova, or it already has, and its light has not reached us yet. If you would like to know more about Betelgeuse, we have made its own video and it's very interesting, because if it explodes in the night sky, it would be the second brightest thing in the night sky, and that's for many years. Let's take a look at Mars's history. About 3.7 billion years ago, the planet Mars looked very much like planet Earth today. You could find massive oceans on this planet. It had a thick atmosphere, and it was also much warmer. As you know, Mars today is very cold, and its atmosphere is almost non-existent. You have a very thin layer nowadays. The era we're talking about, there is a slight chance that living things could have lived on Mars. But unfortunately, the chances of us finding life right now on Mars is quite slim. But if you look at the history of planet Earth, you'll see hundreds of millions of years went by and there was no living thing. Just like the steps and filters that planet Earth went through, where it went from a hell to heaven, why wouldn't Mars go through the same type of eras? In the year 1610, around 400 years ago, Galileo was the first person to talk about Mars and notify it that this is a planet in a solar system. But it took a very long time to actually understand what this type of planet is. We eventually found out in the 20th century when we actually got our hands on proper modern telescopes. This is when we realized that Mars is very close and it's kind of similar to Earth, but billions of years ago. Then again, decades go by, and finally in the year 2011, Curiosity is the first advanced Mars rover that lands on Mars. Like we said, Curiosity was the first advanced rover, and it got us familiar with this unknown planet after many centuries. So if it's true that Mars had a lot of waters on its surface millions of years ago, but why does it look like this right now? Scientists believe even though Mars could have looked like planet Earth right now millions of years ago, what its insides were completely different. After Curiosity, another more advanced Mars rover landed on Mars, called Perseverance. The issues that Curiosity had on Mars, it was solved with Perseverance. The location Perseverance was dropped off was much different than Curiosity. They believe it was a lake bed where it landed at, and its sole focus is to understand the history of Mars and if there's a chance that living things used to live here. And the best place you can start is at the bottom of a lake. About 4.6 billion years ago, when both planet Earth and Mars were being born in the solar system, they were both a fiery planet. They both have an iron core, and that's why they both had a strong magnetic field. Right now, the magnetic field around planet Earth is much stronger than Mars. And this is the guard or the shield of our planet that doesn't allow unwanted UVs to hit the atmosphere and destroy it. The magnetic field basically captures it and pushes it and smashes it into the pole, creating the auroras we all know and love. But Mars could not hold this magnetic field like planet Earth. It was destroyed millions of years ago. When a planet doesn't have a proper magnetic field in front of its star, it's kind of like removing the shield of a warrior in the battlefield. Scientists believe that 3.7 billion years ago, the magnetic field of Mars was destroyed, and this caused the atmosphere of the planet to get destroyed because there was no shield protecting it. But throughout Earth's history, its atmosphere actually got even stronger. Some scientists believe the problem with Mars was that it was small, and when you're a smaller planet, you also have a smaller core, so that iron core cooled off quicker, and that made the magnetic field lose its power. When you lose your magnetic field, you slowly destroyed your atmosphere, and when your atmosphere gets destroyed, all life on that planet will slowly perish. All the water gets destroyed and turned into gas, and when there's no atmosphere, it cannot hold it. So it all evaporates into space, leaving a dead planet behind. And since there is no atmosphere, there's a chance that the water might turn into ice. When we look at Mars, we see the signatures of the water that are left behind. And this is the reason that scientists come up with the theory that there used to be a lot of water on Mars. Just like we said, most of the water on this planet are destroyed. But there are icy caps on the north and south pole, and they believe that's frozen water. And inside these frozen caps, there is a chance you will find ancient creatures. We are not talking about finding penguins on these poles. We're talking about bacteria or single-cell organisms, something very simple. Even finding a single-cell organism on Mars is very exciting because this gives us more knowledge that there is a chance of other life on other planets. It will be the first life that will be found outside of planet Earth, and this could show us how many similarities and how many differences different planets can make. Another interesting thing Curiosity found in the year 2018 is that in its very thin atmosphere, they found methane. Methane is a type of gas that can only be produced by living things. So if there's methane gas in Mars's atmosphere, there's a chance that there used to be life here, or there's still life remaining to this day. Scientists also believe that finding life inside the ice is much rarer than finding them in underground water. Earth has underground water pretty much everywhere. That's how wells are made. So why wouldn't there be underground water on Mars? Some scientists even believe that the methane that remains in the atmosphere of Mars is produced by the animals living underground. Most of these things we're telling you are all theories that different scientists around the world came up with. But they come up with these theories with a whole lot of research that came up with decades of gathering information. But they have three theories, and one of them is the absolute truth. One is that there was never life on Mars. And number two, there was life on Mars, but it went extinct. And three, there was life on Mars, and there is still life on Mars. You might say, congratulations scientists, you don't say. But saying this is very important because one of these three is 100% true. That's one of the many reasons that these Mars rovers are being sent to Mars. But there are also other scientists in SpaceX and NASA that say we will not figure anything out until humans actually land on the red planet, because these machines aren't as sophisticated as the human, so they will never figure anything out that could be final. And that's one of the many reasons both SpaceX and NASA want to land on Mars. The Artemis program that is going on right now in NASA is the first step towards going to Mars. They're gonna set a station there, learn how long travel works, and then they will set sail all the way to the red planet. So even if we find a single-cell organism on Mars, what will that solve? It will help us in all types of factors, especially the knowledge we have of the universe. It could show us how different life could be on different planets, or how similar it could be. Do they have the same type of DNA as the creatures on planet Earth, or are they completely different? This will teach us more about the universe itself rather than Mars. It could also help us in another way. It could show us what the future of planet Earth will be like. Is it going to be like Mars or not? Everybody knows that planet Earth is probably the most unique planet in the universe, at least to us. Between all the planets scientists have seen before, none of them are as beautiful as planet Earth. None of them have this type of blue, green, and brown. This is why planet Earth is also called the blue planet, because of the oceans that takes up most of it. Something else that makes planet Earth much unique than others is fire. You can't find any other planet we have discovered that has fire on its surface. You might say, what about the volcanoes on Mars? Or the sun itself? The entire thing is made of fire. You have to know, the flames you're seeing on the sun are not fire. This is actually nuclear fusion that makes a sun light up. The lava or magma you're seeing that comes out of volcanoes is not fire either. This is actually molten rock or other elements that went under extreme pressures and temperatures, and now they're molten, so it's not really fire. And when you have lava, you do not need oxygen to keep it going. So planet Earth is the only planet we know of that has fire on it. But what is fire anyways? We all know that inside our atmosphere there's oxygen, probably the most important thing in life. But planet Earth didn't always have oxygen in its atmosphere. The first atmosphere that was formed on planet Earth was made up of methane and CO2. About 3.4 billion years ago, that's when life began on Earth, but not the life we all know of. It was actually single-cell organisms that lived inside the waters. With the help of sunlight, water, and the carbon dioxide that was available in the atmosphere, these creatures went through photosynthesis. They continued this for 1 billion years, and the more they go through photosynthesis, they basically turn CO2 to oxygen, slowly filling up the atmosphere with this oxygen we all love. The reason it took about 1 billion years is because a lot of the oxygen in the beginning went inside the soil, especially the iron elements, because most of the iron you find on planet Earth is iron oxide. But let's get back to fire. If fire wants to start, what does it need? Fuel and oxygen. When fire is going, it could produce water vapor and CO2, and it is these types of gases that create this thing we're seeing, the thing we call fire. So the light you're seeing is basically gas burning up. Based on the research scientists have done, even though there was oxygen for a very long time on Earth, that didn't mean there was fire. They say there wasn't fire for about 2 billion years, and the reason for that is because there was no fuel. The first plants that grew on land was about 500 million years ago, and these were the first fuel for a fire to set up. They were basically the very first things that could be set on fire. Earth's history completely shows this, because the oldest ashes we've been able to find goes back to about 470 million years, and they believe these were the very first things that set on fire and fossilized. There are a lot of theories on how this fire started in the beginning, but the strongest argument is that it was lightning, because to this day, lightning could start wildfires. The more we move forward, the more plants grow on land, and the more oxygen they produce to thicken up the atmosphere. The more oxygen you have, the easier the fire will begin and expand. And this gets pretty wild when you get to the supercontinent of Pangaea. You have a whole lot of plants being grown all around this continent. There was also a lot of wildfires on these lands. Scientists believe around that time the percentage of oxygen in the atmosphere was much higher than today. About 350 million years ago, the percentage of oxygen in the atmosphere was 35%, and right now it's 21%. And it is because of this insane oxygen level that insects like that back in the day used to grow this large, like this giant dragonfly called the Maganera. If insects were this large because of oxygen levels, just imagine what type of fires we would have had. The fire that has 35% oxygen level in the atmosphere is going to be much more violent than today's fire. These wildfires would basically destroy all the trees, and because of this happening millions of years on end, it caused these trees to evolve differently, especially to counter wildfires. Like, have you ever looked at a pine tree? It has been here for about 150 million years. Pine trees are basically engineered in a way where they don't set on fire very easily, and if they do, the seed in their fruit is buried so deep that it's very hard for it to get destroyed, and that means you can't make it go extinct easily. There are different types of pines all around the world, but some of them evolved so differently that they are so strong in a wildfire that they don't even die. Everything will get burnt off, but they're still living. And the ashes that are left because of the other plants give them more life because it has nutrients that that tree can use. When you look at the evolution of pine trees, it is truly amazing compared to other plants. It can counter fire, it counters lack of water, and even if there's a lack of sunshine, it still lives on. About 65 million years ago, when a giant asteroid basically made all the dinosaurs go extinct, these pine trees were also living at that time. Because of this asteroid hitting and a lot of asteroid showers, most of the forests all around the planet caught on fire, and of course, other species also went extinct. there was an ash cloud all around the atmosphere that blocked the suns for many years, and that made even more species go extinct. But just like we said, the pine crows went through all this hell, but they still survived. After this took place, another amazing plant started to hit planet Earth. A very simple plant, but very strong. Grass. Grasslands formed all over the planet, and these plants basically changed the entire ecosystem of every place, especially in terms of food, because different species can use it. Even though grass gets dry in the summer, but its roots is always alive, and next time it comes back even stronger. Don't get me started on fire, because that also does not kill it. It also makes it even stronger, because the ash that's left behind basically becomes fertilizer for the grass, and that makes it even better. It is because of this grass that you have different species like wheat and rice. So this shows us that fire came on the planet not to destroy, but to build life. Like for example, when the Homo erectus finally were able to control fire, the speed of their evolution became even faster. One of the most important things is that they were able to cook food, and when you ate cooked meals, that made them more intelligent. And of course, the fire would keep them warm, and it would counter against predators, because most predators are afraid of fire. If you've seen our video about how fire was controlled, it finally allowed ancient humans to finally leave Africa, because when you have fire, you don't have to stay in a warm place and you can go more up north. So when you look at the beautiful blue planet that's called Earth, we realize that it's not just the water that makes it unique. The fire also makes it even more unique. This is the 10th brightest star in the night sky, a star that has been observed for thousands of years by ancient humans. You've most likely seen this star in the night sky, but you never paid attention to it. This star that's very well known is called Betelgeuse. If you haven't seen Betelgeuse, make sure you go see it, because astronomers say that this star will explode in the near future. Years away from us. But even with that, it's still bright in the night sky. And the main reason is that this is not an ordinary star. This is a red supergiant, which is a lot hotter, brighter, and bigger than a normal star. When an ordinary star gets near to the end of its life, it gets bigger and bigger and turns into a red supergiant. It's at the end of its life, but that's compared to the age of the universe, because it still has tens of millions of years left to live. Our sun is gonna go through the same stage in a few billion years, and when it turns into a red supergiant, it's going to get so massive that it will eat up Earth's orbit in the solar system. But let's go back to Betelgeuse. Astronomers say it is true that this star has turned into a red supergiant, but how do they know that it's going to explode in the near future? Scientists and physicists believe that this has been a red supergiant for so long that any day now it will go through a supernova. It could be a few years or maybe even this year. They really don't know. So that means in our lifetime, we could pretty much see a live supernova happen. This is not only very cool to visualize, but it's actually very cool for science, because they can figure out a whole lot of new things they never knew about space and how the laws of physics work. But this will get them there. When a star explodes, it's called a supernova. And this is the first time that we can use modern technology and modern instruments to look at a supernova happen live. The last time this happened in the history of humans was in the year 1052. This is when a star named SN 1054 exploded in the night sky and went through a supernova. And the thing we know is that in every single culture all over the planet, there is a writing about this event. It was written about in China all the way to the Aztecs in modern-day Mexico. They said the star was so bright that you could see it during the day next to the sun. The light stayed in the sky for about 2 years, then it disappeared. Scientists didn't know what this was, but eventually in the 20th century with modern equipment, they exactly found the location scientists were writing about 1,000 years ago and realized that a supernova happened in this location because they can track a nebula that it left behind. That's why it's called the SN 1054 or supernova, and the year it happened, 1054. But SN 1054 is nothing compared to Betelgeuse because that was 6,000 light years away. But Betelgeuse is only 500 light years away. And that means when this goes through a supernova, it's going to be much more brighter in our night sky. We have to be expecting it to happen soon, and it will change our sky for a little bit. Let's look at the size of Betelgeuse. If you want to compare it to our sun, it's 1,000 times wider than our sun. And that means if you put it in the solar system where our sun is located, it will eat the orbit of Jupiter. That's how massive it is. What's the fuel of a star? It's hydrogen and helium, and the sun is the same. Under extreme pressures and temperatures, these atoms turn into heavier elements. And it is this process that makes this star bright and have a lot of heat. It's not actually on fire. Eventually, the hydrogen and helium in the core of a star will run out, and that means the fuel has run out. So it starts expanding slowly and turning into a red supergiant. And after millions of years, a supernova will take place. So what will this event do to planet Earth? Thankfully, it's not a negative one. The only effects are positive because you will see a bright sky, and some may say it's beautiful. Eventually, after a few years, everything will finish because that bright star will turn into a nebula, basically the corpse of a star. But it's a beautiful corpse. But the brightness is so low that you won't see it with a naked eye. Supernova is a very important event in the universe. It is supernovas that created life. Just like we said, hydrogen and helium is the fuel of a star, and under extreme pressures and temperature, they turn into heavier elements. One of those heavier elements is what? Carbon, the most important element in life. But after the supernova happens, carbon is only one of the elements that gets scattered throughout the universe. There are many other elements like lead, iron, or gold. Another weird fact about Betelgeuse, just like we said, is about 500 light years away. So that technically means if we're going to see the supernova in our lifetime, this star has already exploded hundreds of years ago, and we are just waiting for the light to reach us. Scientists say a supernova will be dangerous to human life on Earth if it's less than 150 light years away, because the radiation they give off could be very deadly to us. A supernova radiation less than 150 light years away would put a negative effect on our atmosphere. And scientists believe about 2 million years ago, when a mass ice age happened, it was because of a recent supernova that destroyed our atmosphere and created a very long ice age. Our sun will eventually go through a supernova, but it's still way too young. So in the near future, we're gonna see something beautiful in the sky. It's going to be with us for a couple or a few years, and scientists will get a lot of information on how a supernova actually happens because they're going to witness one live. Scientists say when this explodes, it will for sure be the brightest star in the night sky. We'll just have to wait and see. This is the solar system, something that's extremely unique throughout the universe. But you have to know, around 40 light years away from us, basically right next door in the distances of the universe, there is a star system that astronomers believe that could hold life. TRAPPIST-1. let's compare TRAPPIST-1 to our solar system. The star in the middle of the solar system, basically our sun, is a normal star in the universe. But the star in the center of TRAPPIST-1 is a red dwarf, so it's much smaller, much dimmer, and it's a little bit bigger than Jupiter. This is why they call it a dwarf. It's much smaller than an ordinary star, but it has some positive, which we'll get to. Some scientists speculate that red dwarfs could live trillions of years on end, while a normal star like our sun could survive for about 10 billion years. That's an insane time, but compared to a red dwarf, it's nothing. And you already know that our sun is about 4.6 billion years old, so it's still pretty young. Even though it's possible for life to exist around a red dwarf, but it's rarer than a normal star, because the Goldilocks zone or the habitable zone around a red dwarf has to be much closer to the star. And that means if it's a little too close, it will be tidal locked to the star. That means one side of the planet is always facing the sun, which is very hot and dry, while the other side is permanently night, and it's extremely cold and freezing. You guys should be familiar with solar flares. Basically, these massive explosions that happen on a star, and they throw out these massive flares that could potentially hit planets. And it does. These flares have radiation and are extremely dangerous for atmospheres and living beings. You might say, what about Earth? How is Earth safe? It's because the magnetic field around Earth is pretty strong and it could withstand the solar flares that come from the sun. And that means living beings on planet Earth are safe. Like for example, when you go to the International Space Station, you are outside the atmosphere. You're in space, and that means all that solar flare and radiation is hitting you inside the International Space Station. There's nothing you can do. There's no special suit that could prevent this from happening. Whenever an astronaut enters space, they are accepting that they will be hit with this type of radiation. But let's get back to TRAPPIST-1. The solar flares on a red dwarf is not that much less than a normal star, especially since the planets are much closer to the host star. But TRAPPIST-1 is more unique than you think, because there's 7 planets around it, and 6 out of the 7 planets are in the habitable Goldilocks zone. Something that could not be said about our solar system, because only planet Earth is in the Goldilocks zone. TRAPPIST-1 is an extremely small star system, because its diameter is only 9 million kilometers. And that's in a way the solar system is much more massive. The distance between our sun and Mercury, which is the first planet, is 58 million kilometers. That means if you put TRAPPIST-1 in its entirety in the middle of Mercury and the sun, you still have 49 million kilometers of empty space. But let's see what's going on the 7 planets that orbit this star. The first planet is called the TRAPPIST-1b. Just like Earth, this is a rocky planet, and it's a little bit bigger than planet Earth. And it has an atmosphere, but it's not an atmosphere you're used to, because it's primarily made of carbon dioxide, and it's extremely thick. And that means there is no way that life could exist on this planet. It's also very close to the host star, only 1.7 million kilometers, or 5 times the distance between Earth and the Moon. Another interesting fact is that every 36 hours on this planet is 1 year. The next planet is the TRAPPIST-1c. And just like the first one, it's not very far from the host star, only 2.4 million kilometers. This is also a rocky planet. It's 20% bigger than Earth, and it also has more gravity. This planet also has a very thick CO2 atmosphere. Just like the first one, there's no life here either. The next planet is TRAPPIST-1d. This is only 1 million kilometer away from C, so 3.4 million from the star. 1 year on this planet is extremely short, 97 hours. This planet is much smaller than Earth, only 70%, and that means its gravity is a little bit weaker as well. Scientists say on the first 2 planets there's no way life exists, but on the planet 1D there is a chance, because it's a planet that has oceans. And you know what that means? When there's water on a planet, there's always a chance for life to exist, just like how life began on planet Earth. But let's go see the next planet, TRAPPIST-1e. TRAPPIST-1e is only 4.4 million kilometers away from the star, but you can probably find the best life or the best chance of life on this planet. Each year on 1e is 146 hours, and the best part is that its size is damn near the same as Earth, meaning at 91%, and its gravity is also very similar as well. The temperature is very similar to planet Earth, but its light is much less because it's a red dwarf and it only has 60% of the brightness we have here on Earth. But in terms of temperature, it's a little bit colder than Earth, but it's enough to hold life. But the best news about this planet is that its atmosphere is mainly made up of hydrogen, and that's why TRAPPIST-1e is known as the second Earth, or Earth 2.0. because it's one of the best exoplanets humans has ever found that's similar to planet Earth. The atmosphere, the distance, the temperature, the size, the gravity allows 1e to have oceans, seas, poles, and maybe even life. After TRAPPIST-1e, you have 3 other ones, F, G, and H. F and G are still in the Goldilocks zone, but they're near the edge, so it's much colder. That means the chance of life is much lower here. And H is completely out of the Goldilocks zone. That's why astronomers still believe that TRAPPIST-1e has the highest chance of life that's near us. It's interesting to know, one of the main objectives of James Webb was to research the TRAPPIST-1 star system. James Webb has already examined TRAPPIST-1b and it has figured a lot of stuff out. But figuring this stuff out takes a lot of time, and it's going to basically study the entire system, and when it gets to 1e, that's when it's going to get interesting. You might ask, how can you live right next to a red dwarf? It's interesting to know that astronomers believe it's the most stable way of life to live near a red dwarf. And trillions of years into the future, all living things will most likely be living next to red dwarfs when all the normal stars have already died. These stars could live for trillions of years, and they give the same amount of energy and light. Just imagine this planet has living beings, and it's very close, only 40 light years away. And that means if we have a spacecraft that could go that speed, we will reach it in 40 years. That seems ridiculous, but humans can always dream. What are the most expensive things on planet Earth? Gold? Diamond? Works of art? No, none of that. If you want to get technical, health is probably the most expensive thing in the universe. In some instances, health cannot be brought back with an infinite amount of money. So since we can't properly buy health, let's see what's the most valuable thing. Like for example, diamonds. What would you say if I told you very nearby there's a planet that's completely made out of diamonds? 55 Cancri E, or the Diamond Planet. The Diamond Planet is only 41 light years away from us, and we've said this many times. Such distances compared to the size of the universe, it's nothing. Experts have put a value on the diamond on this planet, $30 nonillion, which is 30 with 30 zeros in front of it. But this number doesn't mean anything, because as soon as this many diamonds hits the market, it becomes worthless. Even diamonds in today's industry is all fake. They create fake scarcity and make it seem like it's something rare. Diamonds are extremely common, but since only a few companies control this filthy business, they can keep the prices high and force people into buying it. But enough about diamonds on Earth. Let's go talk about 55 Cancri E, which is filled with diamonds to the brim. Such distances compared to the size of the universe, it's nothing. It's kind of like your neighbor. But 41 light years is an insane amount of distance for us. Because if you had access to the fastest speed in the universe, at least the fastest we know, the speed of light, it would take you 41 years to get to 55 Cancri E. So if you wanted to get to this planet this year, you should have left in the year 1983. This shows us how massive the universe is and how slow the speed of light is. So let's say we had a machine that could go at the speed of light and we got here after 41 years. The first thing we'll notice is that 55 Cancri E is a part of a binary system. That means there is two stars, 55 Cancri A and 55 Cancri B, while the planet is 55 Cancri E. Might sound confusing, but that's what it is. The reason these planets and stars have so many numbers and letters that are random is because there's so many in the universe, and when astronomers and physicists discover these, they can't just give it any old name. They have to give it a VIN number, kind of like a car. You have to put a VIN number on it to identify this chassis. You can't just give a name for anything because you will run out of names after a few days. Let's look at the two stars that are in this system. 55 Cancri A is much bigger than 55 Cancri B. And the funny thing is, 55 Cancri E is very close to the big star, meaning the A. Alongside the distance of the universe, this planet is literally touching its star because it's only 2 million kilometers away from it. This is an insane distance. Like for example, Mercury is the closest planet to our star, but that's 69.8 million kilometers away from the sun. But the Diamond Planet is only 2 million kilometers away. So that's clear. If the planet is that close to its close star, there is hot molten material on the surface. And that's exactly what's happening on 55 Cancri E. Physicists believe that 1/3 of the density of this planet is made from carbon. And wherever there is carbon, there is always a chance that you will find diamond in that location. As you know, diamonds is made purely from carbon, but carbon that has been put under a whole lot of pressure. Time doesn't really matter because in our laboratories, you could literally form artificial diamond, and it is as legit as it gets. It's actually even more legit than a natural diamond because its structure is much more organized. But either way, a natural diamond will bring a whole lot of money, even though the artificial is just as good or even better. So we conclude that all this carbon on 55 Cancri E is under infinite amount of pressure, and it has for sure turned into diamonds. Since this planet is so close to its host star, the temperature is insane. About 2500 degrees Celsius. You might not believe how insanely high that is, because this temperature is enough to melt rock. They say if you could get close to this planet, you would see a planet with molten lava on its surface. Kind of like when you see planet Earth with blue oceans and seas, but you see a fiery red planet if you were close to 55 Cancri E. To compare this insane temperature to one of the planets on our solar system, you have to compare it to Venus, the hottest planet in the solar system. This planet has a temperature of 464 degrees Celsius. That means it's not even 1/5 as hot as the Diamond Planet. The size of 55 Cancri E is twice as planet Earth. but its density is 9 times Earth. And that's why if you could go on top of this planet and stand on its surface, you would feel a lot heavier. Like for example, if you're 100 kilograms on planet Earth, you would weigh 220 kilograms on this planet. Like Jupiter's gravity is 2.5 times Earth's, so you would weigh 250 kilograms. You might ask, how do you know what the gravity of this planet is and how it works? Well, I don't know, but the research that has been done by physicists and astronomers says that this is the correct theory. Let's just say we have an insane amount of technology and we have some clothing that we could land on top of the diamond planet. Where can we find the diamonds? Because we flew all this way to find some diamond and get rich off of it. Well, the first place you should be looking at is next to volcanoes. Just like planet Earth, all the diamonds that were cooked underneath the crust eventually came out with the help of volcanoes. So in this planet, it is probably the same case, since all that carbon is underneath the crust, and sometimes all those diamonds will get spat out. Another insane fact about the diamond planet is that it rotates around its star in only 17 hours. That means 1 year on this planet is only 17 hours long. Just like we said, Mercury is the closest planet to the star. 1 year on this planet takes 88 days, and that's because it's rotating at a super fast speed. Imagine how fast 55 Cancri E is going. You might ask, what about the second star, 55 Cancri B? We have to say that 55 Cancri B is a much smaller star, and it's extremely far away from these two, and it doesn't really have an effect on the planet or the star. The star system that has these planets in it is called the 55 Cancri system. It has 4 planets and 2 stars. 55 Cancri A and B is the stars. Then you have 55 Cancri C, D, E, and F. But the most famous planet alongside all this is the 55 Cancri E, or the diamond planet. And the address is 41 light years away from us if you ever wanted to find some diamonds. One of the most interesting bodies in the solar system is a moon. The largest moon of Saturn, called Titan. Unlike any other moon, Titan has a very thick atmosphere, and astronomers believe that there is water on this planet. Let's get closer to Titan and take a better look at it. Saturn has more than 140 moons, but most of these moons are very small, but Titan is the largest and most interesting one. The diameter of our moon is 3,474 kilometers, but Titan is 50% larger, and it has a diameter of 5,150 kilometers. It is also the second largest moon in the solar system. Ganymede is the largest moon in the solar system, which belongs to Jupiter, but these moons, including Titan, is much bigger than you think. Like for example, Mercury, the first planet of the solar system, is smaller than Titan. What type of gravity does Titan have? Because it's extremely important for life. There is gravity on Titan, but it's only 14% of Earth's gravity, so it's extremely low gravity. If you compare it to the moon, our moon has even more gravity at 17% of Earth's gravity. But this doesn't make sense. We thought Titan is unique, it has gravity, and there's a chance we could live on it. As you know, Saturn is extremely far from the sun, so it means it has extremely low temperatures, and that means Titan is very cold, right? This is correct because on Titan you can only find rocks and ice. But physicists believe that under these layers of rocks and ice there is an ocean, and that might mean there is life in these waters, because anywhere there is liquid water, there is a chance that life could exist. But these are all theories because you can't be 100% sure that under these layers there's an ocean. In the year 1997, NASA and the European Space Agency worked together to design and create a probe to send to Saturn to study the planet and its moons. A probe that you might have heard of called Cassini. Cassini was mainly designed to study Saturn, but another body that's next to it was Titan, and that was also important. And a lot of the information we have on Titan is thanks to Cassini. Unlike many planets, Titan does not have a magnetic field, so if any solar storm happens, Titan is screwed. But the thing is, the big planet next to it named Saturn has an extremely strong magnetic field that protects all its moons, including Titan, so it is safe from solar flares. Just like how the moon is tidal locked to Earth, Titan is tidal locked to Saturn, so you could only see one side of it, and each rotation, it only rotates around itself once. But the thing is, Titan rotates around Saturn every 15 days, and our moon rotates around Earth every 27 days. But every new moon to new moon is 29.5 days, and that's basically where the month comes around. Have you ever seen pictures and photos on the moon where the sky is black? Why is that? The reason the sky stays black on the moon is because there is no atmosphere. When there's no atmosphere, it's basically like being in a vacuum. There is starlight, but it doesn't shine on anything. The reason we have blue skies is that our atmosphere turns the sunlight into a beautiful blue color and scatters it around the world so you can see a blue sky. So it's thanks to our atmosphere that turns the sunlight into a blue color instead of a never-ending black color. On Titan, the atmosphere is so thick and dense that you can't even see what's going on the planet, and if you were on the surface, you couldn't even see the sky. But when the sunlight hits this dense atmosphere and you were there to experience it, you would see a greenish yellow color because the atmosphere is that color. The thickness of Titan's atmosphere is insane because it's 7 times the density of our atmosphere. A lot of scientists, astronomers, physicists believe that there is a chance that life could exist on Titan, but not on its surface, underneath the ice and rock, where there might be an ocean. Even though this planet rotates around itself every 15 days, but its atmosphere rotates around the planet every 9 hours. And that means there are insane storms on the surface of this planet, storms that go hundreds of miles an hour. But what is Titan's atmosphere made of anyways, and why is it yellow? Its atmosphere is made up of 98.5% nitrogen, 1.4% methane, and 0.2% hydrogen. And if you compare it to Earth's atmosphere, it's 78% nitrogen, 21% oxygen, 0.9% gases like argon and other, and 0.04% carbon dioxide. Just like we said, Titan's atmosphere has methane, and you could get methane from 2 different ways: volcanoes or living organisms. There is methane on Titan, but the other 2 we're not sure of. We're not sure if there's volcanoes or living things. Titan's surface is extremely cold, minus 180 degrees Celsius. And that's why anything that's not rock is frozen. It's interesting to know that when they sent Cassini, they also had a lander named Huygens. Since the atmosphere is so thick on the Titan, they were forced to send the lander to maybe see what's going on the surface of this moon. So when Cassini got there, it released Huygens so he could finally see what's happening on the surface. This is not a very sophisticated lander like the Perseverance Mars rover. It's a very simple machine, and it's designed to take a video and one picture when it lands. And this is that picture. As you could see, it kind of resembles the bottom of a dry ocean, where there are rocks and sand everywhere. Cassini stays for many years around Saturn and Titan to study it, and it even realizes that there is a lake that's not frozen. A lake called Kraken Mar. This is an insanely large lake, over 400,000 square kilometers. You might say that doesn't even make sense since the surface temperature is a minus 180 degrees. But you have to know that these lakes are not made from liquid water. They're made from liquid methane, which stay liquid in this temperature on this moon. Studies have shown that the depth of these lakes is more than 100 meters. But of course, in the methane, there's no way living beings exist. But there is a chance that underneath the sheets of ice and rock, there could be oceans, and there could be living things in those waters. Cassini got there, studied this planet and its moons for many years, and after 20 years of service, since it had no other options and it was running out of fuel, NASA told it to crash into Saturn and destroy itself. But NASA's job was not finished studying Saturn, especially its important moon Titan. After Cassini ended, they started another project. They started designing a drone called Dragonfly. Dragonfly is basically a very sophisticated drone that's being designed to be sent to Titan and fly around the moon and completely study it. And it's going to be much better than the Huygens lander that was sent 20 years ago. The Dragonfly project is designed to be sent out in 2028. But it's going to take a very long time before it gets to Titan. It'll take 6 years, so it'll be there by the year 2034. So 3 World Cups have to come and go, and then finally, Dragonfly will get to Titan. But it is extremely interesting. Imagine this drone gets to Titan and fly around this moon that is barely known and find new things. And maybe there is a chance that it could find signs of life, or maybe ancient life. What do you guys think? Scientists and astronomers think there's a lot going on Titan that we don't know much about, and that's why they're going through all this trouble and spending all this money. If you go on our channel and look at the space videos we upload, we have plenty of them in there. So in this video, we're back again talking about space. If you've seen space videos, you know that the weird stuff and interesting things are pretty much endless. Any corner of the universe you look at, there's something interesting to see or talk about. Some of them are extremely interesting, some of them are very weird, and some of them are extremely terrifying. Like for example, the neutron star, or even scarier than that, magnetars. Before we start talking about magnetars, let's look at neutron star first and then we'll move on. Neutron stars are very similar to magnetars. What you're seeing is a neutron star. In simple terms, the way a neutron star gets formed is that a red supergiant, basically a ginormous star, gets to the end of its life and it finally explodes in a supernova. When a star explodes through a supernova, it pretty much scatters all its guts through the universe, and the gas and debris leaves a nebula. But now, the core of the star that used to be there has now turned into a neutron star. Not every time a neutron star is formed by this. It only happens when there's so much temperature and pressure that it causes the electrons and the protons to fuse together and turn into neutrons. That's why these stars are considered neutron stars. These stars aren't ginormous whatsoever. They're only 20 kilometers across. But the insane part is that even though it's only 20 kilometers wide, its mass is greater than our sun. Just imagine the density of it. If you've never seen this is called a thimble. Sewers put this on their finger so the needle doesn't go through their finger and it doesn't help them when they're working with it long term. But if you take this thimble, which is extremely tiny, and put neutron star material inside it, can you guess how much it will weigh? You're not gonna believe it. It will weigh 100 million tons. 100 million tons is 15 Great Pyramids of Giza. Just thinking about the sheer weight of this thing is ridiculous. And another interesting thing is, neutron stars spin around themselves so fast that they have the fastest rotation in the universe. At least the fastest we know of. This is the fastest neutron star in the universe that has been discovered. PSR J17482446 AD. This neutron star spins around itself at 24% the speed of light. If you want to understand the speed a little bit better, it rotates around itself 716 times a second. This was a terrifying star, right? But you have to know there's much more terrifying than this. Magnetars. Another way you can calculate the gravity of this star, if you were to stand on top of it, you would weigh 2 trillion times the weight you weigh right now. But the funny thing is, the magnetar is 1,000 times the neutron star. Physicists and astronomers believe that magnetars have the strongest magnetic fields, and that's why it has the name magnetar, which comes from the word magnet. Magnetars are the only stars that an earthquake, or should I say magnetar quakes, could happen. It's not like the earthquakes we're familiar with where tectonic plates causes it. In some of these starquakes, the crust of the magnetar could crack and a huge burst of energy could exit the star all of a sudden. But it's not like it's a laser shot. It's actually radiation. Radiations that are so powerful that you could detect it millions of light years away. In the year 2004, one of these giant beams reaches planet Earth. But thankfully, the radiation came from 50,000 light years away from us. A beam that came from this magnetar, SGR 1806-20. When this burst reached planet Earth, it changed science forever, and physicists got to know what these magnetars are actually capable of. They realized that these magnetars will release so much energy in 1/10 of a second that it could be comparable to the sun's entire life. It's basically releasing more energy in 1/10 of a second than our sun does in its entire life. Thankfully, these radiation waves were extremely far from us, so they didn't have a negative impact on our planet. But physicists believe if a magnetar is about 10 light years away from us and something like this is shot towards our direction, it's gonna be a huge problem. Because first of all, we don't know it's coming. And second of all, if it hits us, it first destroys our atmosphere completely and turns the entire planet into a hell. That basically means planet Earth will no longer be able to sustain life. The worst part is that you could never predict when a star quake is gonna happen on a magnetar. The only way you could realize this has happened is that if it already hits you, and that means it's too late. But the good news is that scientists believe that there is no magnetars nearby. The closest magnetar is XTE J1810-197, and it's 8,000 light years away from us. And that's a fairly safe distance. So when a star quake happens on a magnetar, what type of radiation is released? Gamma rays. Gamma rays are the strongest and the tiniest waves. And in simple terms, they'll pass through anything and destroy you. Gamma rays are very similar to radioactive radiation. In chemotherapy, gamma rays are strategically used to kill cancer cells. Even though they kill cancer cells, they also kill a lot of healthy cells, which is why a person that goes through chemo lacks a lot of energy, and they also lose their hair. But chemotherapy is only a little bit, and it's in a specific area. But gamma rays could be very much seen in the Chernobyl explosion in the Soviet Union, or the atomic bombs in Hiroshima and Nagasaki. But these radiations on Earth are nothing compared to the radiation that comes out of a magnetar. Neutron stars on magnetars use so much of their energy per second that they have a very short life. At least a short life compared to other stars, because they die very young. They go so full throttle that they will run out of energy in 5 million years. But what happens when they die? They turn into white dwarfs. So what is the point of magnetars and why should we study it? Things like this are extremely interesting for physicists and astronomers because they could learn from it. Maybe they could figure something out and they could invent it on planet Earth right here, because something that creates and releases this much energy could be useful even if we could imitate it just a little bit and use that unlimited energy here. But you also have to be extremely careful, because if you mess around with it too much, you might make something that ends the world. Even though we're in the summertime, just imagine our planet is completely covered in ice. Scientists believe if you want the entire planet to be completely frozen, where even the oceans are completely frozen, the average temperature of the planet has to be minus 130 degrees Celsius. Some may say that this will never happen, but you have to know, this has happened twice in Earth's history. The last time our planet was completely frozen was about 635 million years ago. The scientific term for these eras are cryogenian. There's also an easier term that scientists use, snowball Earth. The first question that comes to mind is that why is the entire planet covered in ice? The main problem are volcanoes. It is basically the volcano's fault. How can a geologist or a scientist realize that if Earth had an ice layer, or what happened millions of years ago? The way scientists and geologists realize that this took place is because of drop stones that are found between the layers of planet Earth. These stones were basically between the thick sheets of ice on the planet. But all of a sudden, when the Earth started to get warmer and the ice started melting, and that created icebergs that sat in the middle of the ocean, the same one that hit the Titanic and made it sink. In this era, icebergs weren't found everywhere. They were pretty much found all over the planet, even next to the equator. And since there were icebergs everywhere and between the ice there were rocks, after they melted, they will release these rocks and let it down into the layers of the history of the planet. And that's why you can find drop stones in the layers of the history of the planet. And you can find these everywhere. It is because of these drop stones that geologists and scientists can realize at what time an ice age was happening. When an ice age is over and the ice starts to melt, you can find a whole lot of icebergs in the oceans. Of course, right now we have a lot of icebergs close to the North and South Pole, but these aren't as big as the ones you would find 600 million years ago. Right now, next to the equator, the average temperature throughout the year is 31 degrees Celsius, and an iceberg will not survive in this type of temperature. But that leaves one important question. Around 635 million years ago, when the entire planet was covered in ice, were there any animals on the planet? What happened to them? At this time, on the surface of the planet, there were no living organisms. But once you went through the ice sheet and entered the waters below it, you would find small microorganisms. These were not complicated creatures, they were basically bacteria and sponges. Scientists believe there was a chance on the surface of the ice there were bacteria living there, because nowadays you could find bacteria living on the ice sheet in the North Pole. But what about the volcano? How did volcanoes create this ice age? You have to know that the planet's atmosphere and its entire ecosystem is very complicated. One of the things that makes it more complicated is that there always has to be a certain amount of carbon dioxide that's released and it has to enter the atmosphere. This keeps the weather stable on the planet. The volcanoes do this job perfectly. At least they usually do, and they release the right amount of carbon dioxide that our atmosphere needs. But how did volcanoes cause the entire planet to turn into a snowball? Around 700 million years ago, geologists believe that most of the volcanoes around the planet started releasing basalt rocks. Basalt rocks are basically a type of filter that does not allow CO2 to be released from the volcano. They basically capture it just like a filter. What the basalt is doing right now is not allowing enough carbon dioxide to go to space, and that causes the CO2 levels to go down. And when CO2 levels go down in an atmosphere, that's when the planet goes extremely cold and an ice age begins. CO2 is a greenhouse gas, and nowadays we're very familiar with those. When there's too much greenhouse gases, that causes the planet to warm up. But if there's not enough, the opposite happens. When there's CO2 or any other greenhouse gas in the atmosphere, it absorbs a lot of heat and it does not allow it to escape, and that causes the planet to start getting hotter and hotter. A lot of people say it's because of too much CO2 that nowadays a lot of people are saying climate change and global warming is happening. But let's go to several hundred million years ago, where the basalt rocks are absorbing all the CO2 being released from volcanoes. Just like we said, this makes the planet start to cool off, and when you add a whole lot of time, it gets colder and colder. But the volcanoes are speeding up the process, and the reason for that is they're sending a whole lot of sulfur into space. Sulfur is a type of gas that doesn't allow heat to be absorbed or even pass through. So just imagine a whole lot of volcanoes throughout the planet releasing CO2 that's being absorbed by some rocks, and they're pumping sulfur into space that doesn't allow heat to pass through it. We have made a complete video about sulfur on our channel if you would like to check it out. Not only does sulfur not allow heat to pass through, but they also don't allow light to pass. And that's what they call a nuclear winter. The skies are extremely dark, no light and heat gets passed through, and it gets extremely cold extremely quickly. You have to know that ice, compared to water, does not absorb heat like water. Water absorbs the heat, but ice reflects it. And when light gets reflected, that basically means heat is getting reflected. Another good example is a white and black car. Ice is like a white car, and water is like a black car. And if you go in the summer and touch a white car or a black car, the black car will be significantly hotter than the white one. So this causes the planet to be a complete snowball for about 20 million years. After all that time, the volcanoes once again activate, but the basalt rocks are so frozen that they don't absorb the carbon dioxide like they used to, and that causes the volcanoes to pump all that CO2 to space. Slowly, the atmosphere CO2 levels rises, and that causes more heat to be trapped inside. And this makes the surface of the planet start to heat up. Geologists and scientists believe that this process took about 15 million years. After all this ice melts, the creatures that were living inside the water got more and more complicated. And you could say this is when we go from single-cell organisms to multicellular organisms. The only multicellular organism that survived throughout this were sponges. To this day, you can find sponges throughout the world, and they're considered creatures that you cannot kill. the planet started to heat up, and this caused the creatures on top of it to get more and more complicated and cooler. It's interesting because nowadays humans are helping the heating up process because they're creating CO2 and pumping it into space. And that's why people are saying that the planet is getting hotter and hotter. What do you guys think?